Hello everyone. This is one Western Digital SMR hard drive data recovery case study, and this is one remote case study from India. Now we can see the drive is detected properly, and the model number is WD20SDRW. So we can see the PCB number is 830067. Click OK. Now let's see what's the issue of this drive. Now we can see its UA writing locked, and we can access the firmware error directly. Let's see, open the firmware directory and check what has been done by the client. So the client has already back up the important modules, and let's see the key module. So it seems module 190 is not backup successfully. It has 190 error. So we need to make sure this one can be backed up successfully, because this is the most important one. And to do this one, we need to disable the 411 and check logs, execute firmware restart. For this kind of SMR drives, if users don't disable the 411, and this will help to destroy the data, because the model 190 keeps changing. And let's see further. Now in snog window we can see the module 411 has been disabled. So let's go to the firmware backup and read modules again, module ID, and we can unselect all modules. We just need to backup module 190 because the user failed to back up this one successfully, and there is something wrong with this. So let's try again and see. Okay, now we can see copy 0 module 190 has been backed up successfully. Right now we can try to sort all the modules and then test selected ID to see if there are some other firmware corruption by this one. The green means the module are in good status, and the red cross means the module's checksum has some error. Now we can see here the checksum error. So the firmware test doesn't pass, and we get this red cross. The software is starting to test this module 190, and in many cases, because the module size is very big, and sometimes we get the checksum error here too. And for this way, we can double click and generate the checksum and then check the modules again. Because this module is big, so it takes a little bit time, longer time than other module test. We can see here there are some user password here, and we can try to use the common unlock smartware and check again, and we can check other modules and say okay, most modules are in good status. So module 411, module 190. And we can try to generate a new checksum for this module 190. According to the user's feedback, we know this drive, the user tried to image this pension drive, but it's very slow. So to fix the slow issue, we have backup as module 190, and we can try to set up the head map, and then we can test the heads one by one. That means we can image some good hits first. Maybe there is one or two weak hits like this one. So we back up this to test the head, because to set up the head map we need to load module 190. Okay, let's check the module 190 hex data. So we can see here as nodes. The hex data here in the middle, we can see these are the valid nodes, and the hex data are in good status here. And we can try to select all and then generate this module checksum, and right click to check the module, and then click write. After writing, we can tick the module 190 and test this module again. The family name charger and microcode here. Now let's test this module and see if the checksum error has been fixed or not. We can see the testing speed is higher than writing speed. Okay, now we can see it's green. So let's check further. Because we have checked all other modules are good, especially these key modules, key data recovery modules, and some modules are not important, so we can ignore them. Now let's check this module editing. Okay, features. Okay, we can disable this one. Click OK, and we can go to the DFO DDP to delete the unnecessary modules to make it faster. Now SATA 0 DFO DDP Western Digital, and change this configuration, modify module 1, modify module 2, and we can try to edit this one too. So 200. This is one test number to get it working properly and quickly. So click OK. And let me check the working parts, the firmware working parts, and T2 data here. This is a T2 data model, T2 data BIN. Okay, so we can go back to the WD and switch back by click on the power icon, ROM operations, enable the module 411. Okay, now I can try to refresh ID. Setting, okay, need to firmware restart. Whenever we have just modify the ROM, we need to restart firmware. And let me refresh ID again. Now we can see the model number. It has been detected properly, and capacity is good. Hex. Now let's check the hex data of this drive. And then let's say, or we can go to the DDP to check the hex data. It's easier and quicker. Hex view. Okay, click hex view. Get ID information. When we try to get ID information, we can see the data is encrypted. So let's try to load the T2 data and see if it's possible to view the data, the decrypted data directly. Here, T2 data. Let's try to note this one and see. It has error. Let's check log window. We can try to load again. Okay, let's see. ATA commands, alt reset. Because this is SED encryption, and let's see if it's possible to load again and see. Okay, now we can see T2 data load successfully. Now let's check the hex view again. Get ID information. So we already know the T2 data again, but it's still encrypted. So right now, we need to go back to the original USB PCB. That means we need to install the 83067 USB PCB, original PCB to this pension drive, so that we get the decrypted data. Okay, because the firmware issue has already been fixed. The only issue is this data encrypting issue by the SATA interface. And this is the SATA USB to SATA SED encryption. We need to use the original PCB for data decryption. Another method is to transfer the MCU from the original PCB to this firmware SATA unlock PCB. Okay, so that's the solution. Thank you for watching the video.